Okay, picking up where we left off on page 457, we're talking about the terms cohesion and coupling. And these are kind of object-oriented kind of terms, but they're very important, and as I already mentioned, they're absolutely positively are going to show up on the test. So now would be a good time to know. Okay, so cohesion is a measure of the module's scope and its characteristics. And basically what it's saying is cohesion means you should write a module that does only one thing. So for example, if you have a module that does report preparation, okay, that's all it does. It doesn't calculate salaries, it doesn't do anything else other than just report generation. And if you do this correctly, you could pull that module out and put it in another application without any issues whatsoever, because all it does is one thing. You've broken it down to its fundamental parts. Okay, so cohesion is another way of describing isolation, that it only does one little thing. So it's isolated. Well, maybe isolation is a poor choice of words. Anyway, it's a singular idea. It does one and only one thing. Now contrast that with coupling. Coupling means that these things should be interrelated kind of loosely, so that if I change one thing over here in this one module, it's not going to affect the thing over here. So yes, of course they're going to be coupled together. Otherwise, your report generation routine would never be able to do anything, because it has to receive information from some other module. But the point is that it ought to be configured so that I can tweak something over here without having to mess with something over here. So loose coupling. And the way you describe it is I want high cohesion and low coupling. Okay? High cohesion and low coupling. Alright. They talk about a structure chart. When you're trying to put together the structure of an object-oriented kind of a scenario, even before you get to object-oriented, you really kind of need to know the flow of something. So I'm going to show you a real-life example of one of mine. And this will probably be a little bit easier to go through than some of their examples. So I have a Visio diagram here, and let me go full screen on this guy. So this is just a diagram of one particular function. In fact, hang on a second, let me see if I can yeah, here we go. So this is an overall program architecture for an application of mine, and you can kind of see it's split kind of sort of right down the middle, where these are the supervisory and maintenance and management functions that are rarely done, and here's where the users actually work. And so I broke it up, and I made little lines here. I'm not sure you can read all of that. A line here that this is the user service layer, this is the business logic layer, this is the data abstract layer, and here's the physical database. And I even show how you get from, how do you cross that boundary? You cross those boundaries using entities, and here you cross that boundary using classes, and here you cross that boundary using table adapters. I'm not going to go all the detail. The point is, this shows the top level architecture of an application. It shows the flow of things, and for example, that whenever you're getting ready to spend money, all the spending is funneled all through one particular operation. You can't get to the database without going through a financial transaction of some sort. And so it describes the security boundaries and all those kind of good things. So it's a pretty cool chart that basically shows the overall architecture. This is an excellent way to demonstrate something to management. I even have an example of one particular one where I zoom in on one particular thing on spending money for overtime. And we have an overtime class, and then we have something in the business logic layer, and how it has to go through a spend transaction and all these other things. So different layers. You can zoom in and zoom out, but I'm not going to go into that much detail. Whew. Okay, on page 461, they talk about object-oriented programming one more time. And, you know, individual objects are designed to do just kind of one thing, and they have some really cool ways of describing them. So what I'm going to do is show you, again, a real live one. So here is an object-oriented, this is basically a class diagram. Now, I do not have the little connecting lines showing how everything is related. I don't have that. But this is a class diagram and it shows all the properties, all the methods, all the things that can happen in this thing. It fits on one page. It's kind of nice. It's kind of, if you're in the middle of programming something and you need something about a user but you can't remember what it's called, you can go down here and it goes, oh yeah, delete user. That's what it's called. I knew it was something. I thought maybe it was, you know, delete, but no, it's delete user. And so this is kind of good documentation that shows you how things are all put together. It shows all of the properties of each one of the classes and all the things that it can do. The nouns, you know, the properties, and then the methods, the verbs, the things that it can do. So that's a good example of an object-oriented class diagram. The only thing different here is I don't have the little lines showing the relationships. Okay, on page 462, they continue on talking about the main objective is to translate these methods into code modules. In other words, if you started with this diagram saying, okay, I need something to delete a user, you could just do this, get this far, and then hand that over to a programmer and saying, your tasks are to write those methods. And as long as you describe them well enough, they should be able to just take that task and run. So they have to know, what method, what the actions are, and what triggers those methods. Remember all from the data flow diagram and all that stuff? It talks about determine the event or message that will trigger the execution of an individual module. Yeah. And you analyze the sequence diagrams and state transition diagrams to show the events and methods that can trigger those changes. Yeah, makes sense? Remember all that? Okay. And then, of course, they talk about cohesion and coupling one more time, about these things ought to be separatable. They ought to be, I could be able to pull this chunk out and put it someplace else, those kinds of things. And it's supposed to be loosely coupled, but okay, let's continue. On page 462, they talk about Agile one more time. And so Agile is a highly iterative process. It's designed to get the users involved very tightly and ask them, what's up? Let's do it again, let's do it again, let's do it again, over and over and over. And it is pretty doggone cool. And they talk about how the process works. You start with asking the user for a scenario and what we call a short story. They give you a short story. Now, this is their view of what this thing is going to do. And it may not be everything. For example, if you went to the finance guy and said, what's this thing going to do? He's going to say, oh, well, it's got to do this, this, and this. But you're talking just to the finance guy. When you go talk to somebody else, you're going to get a slightly different list of things that it's going to do. So you have to get lots of these little short stories, and you're going to have to kind of meld them together and then say, is this what you had in mind? And they go, well, yeah, but what's that? And you go, well, somebody else wanted that. And they go, oh, okay. And then you proceed on. So, once again, Agile works pretty doggone good if you have excellent communicators. Excellent communicators on the development side and excellent communicators on the user side. If I mentioned to you a scenario before, one of those extreme examples where, let's say there was a corporate merger and they have a financing system that they absolutely love, but for corporate compatibility, the new company comes in and says, no, you can't use that one anymore, you have to use ours. And so they come in with a system that they don't want. All right, think that through. You're in charge of developing a system that they do not want. In fact, they hate the new system. Now, you're going to sit down with them and say, so, give me a short story on how this thing's going to work. You think that's going to work well? People that are excited about the new project Agile's going to work fantastic. Now, they could be not excited for lots of reasons. They could be excited because they just don't care, or they're not technical enough to get excited, or on the extreme, they don't want the new system. Doggone it, they much rather you just go the heck away. Okay. So again, these short stories aren't going to have much technical information, so you're going to be translating, technical, to help. Okay, 464 they talk about, extreme programming, which is just kind of another version of Agile. And one of the things extreme programming they do is they emphasize is teams, where you have one guy coding and you have one guy basically watching. Now, it sounds a little silly, but it works really well if you're trying to get, junior programmers involved. It also provides, that forest and the tree concept. You got one guy who's so deep into the weeds on doing the coding, you really need somebody covering over them. Not 100% of the time, guys. Come on, give me a break. But you need somebody looking over saying, yeah, but what about? The big picture kind of guy. And so extreme programming allows this teamwork kind of a concept that allows for the forest and the trees. And it works. Okay, on 465 they talk about the future of Agile. And there's some pretty cool, pluses and minuses that we talk about. It's very popular. And yes, it does speed up the processing, and the customers, if you have excited customers at the beginning, you're pretty much guaranteed to have excited customers at the end. That is a fantastic thing. You have got buy-in beyond belief because they feel like they participated. And quite frankly, they have. They've helped develop the project, and they're going to love it when you're done. Now, what about the other way? What if there's complete apathy or hatred for the new system? Then, of course, Agile isn't going to work so well. And, of course, you could skip some technical things, or you could miss the big picture. There's lots of possibilities that things could go wrong that might not go wrong if you had a more structured approach. Because management might know something that the users don't know. Manager might say, we're going to close that plant in Chicago next year. But he's not going to tell the users that. And so the users saying, man, we need this little function over here that integrates that with the Chicago plant. Work on this. And, you're spending your time working on something that's not needed because no one told the users. So yeah, it's kind of a risk. Now, again, I've told you guys before, I'm not against Agile programming. It's actually a fantastic tool. It is great if you have a very involved user base. If you got users that are already working to death and have no time for you, okay, you might not get exactly what you had. Okay, on page 465, they actually talk about the coding. Okay, now that we've done the kind of the overall design, now it's time to actually do the coding. And they have programming environments. You can program in Visual Basic and C# and Ruby and Python and Java, and there's lots and lots of different languages. Which language you pick is kind of sort of up to you. What most people do is they pick whatever language the company or the organization is most comfortable with. You rarely want to go with something brand new that just came out because no one's going to have experience with it. They talk about the Integrated Development Environment, IDE, which means you launch one application and it helps you do the entire program, does all the modeling, does all the coding, does all the compiling, helps you do everything. Okay. On page 466, they talk about testing. And yes, you have to do what we call desk tests, where you just kind of, as you're coding the thing, you can kind of look at it and go, that looks like that might not work. So we do like a code review when we pass things around and say, take a look at this and see if it makes any sense. And oftentimes you'll get a lot of recommendations. You won't necessarily find errors, okay? But the code review process works really well when you have a bunch of junior programmers, because you'll see somebody, I'll be working on the overtime module and you'll be working on the TDY module, and they're very similar in scope. And so I'm doing a code review and I'm reviewing yours and I go, wow, that's pretty dang cool. Maybe I should use that technique. So again, the code review is not necessarily to find errors, it's to help you grow as a team. Okay, this is probably a good place to stop for the 15-minute mark, and we'll pick this up in just a few.